tell you a little bit about myself. I've been in the industry for about 30 years doing network design, configuration, and so forth, diagnostics, mostly in the enterprise world. And at my last startup, I was the chief developer of the product that was the first version of IBM's NetView Performance Monitor for TCP/IP. So I'm a developer too. And now I have my own company, Inside Products, and we do a lot of stuff, including IPv6. A lot of what I'm going to tell you is going to be from the enterprise point of view, because that's who a lot of the people that I deal with are. The large financials, large insurance companies, and so on. But I think really a lot of what I'm saying can hit home to you in terms of what happens in your lab. And the other thing I'm going to say too is I'm not going to talk about a lot of the stuff. You know, people have talked a lot about 6RD, NAT 6.4, all that kind of stuff. This is a totally different presentation. What we're going to do is we're going to have some fun and think about what happens once you start that lab going. Once you get that lab going and you get traffic, now's when the fun starts, okay? So we're going to start looking at packets. And now, as I say, if I got a crew of people sitting here thinking that looking at packets is going to be fun, this is like very sad, right? Very, very sad. But that's what we're going to do. Okay? So let's go backwards here. Oh my goodness, this thing is going ahead of me. Where's the little... Okay. All right. So why are we talking about forensics and packets? Well, first of all, because no matter what kind of network you have, there's only one thing that's for sure. One thing that is for sure, and that is that you're going to have problems. It's kind of like death and taxes. That's the only thing that's sure. How do I get this thing to go backwards here? Go backwards. This is not wanting to I'll tell you, this is like a teenager. It's not wanting to listen to me. What's that? This one? Okay. Sorry about that. Okay. And then it goes back this way.
So this will advance your slides, and this will back them up. So let's make sure it'll actually grab first.
Okay.
It just needs enough time to
Yeah.
install.
Okay. No, but I want to go backwards. Shifts. Back arrow. No, it's not wanting to do that. Sorry about that. Okay, anyway, so we're talking about packets. And sometimes when you've got problems, the only thing to do is to take a trace. And why? Because packets don't lie. When you take a trace, you will see exactly what is going on over the wire. Isn't that right? I see people nodding. That's right. Now, the only problem, though, is figuring out what just happened. Because you know what happened with IPv6? They have changed the entire protocol. And so everything that you used to know with IPv4, you do not know anymore. You have to start all over again and look. And so that's what we're going to do, is we're going to take a look at some of these packets. We're going to look at DNS, neighbor discovery, and so on, because that's the first thing that you're going to run into, is let's figure out what just happened to DNS on our new lab. All right, let me go back here, see if I can get a control of this thing here. I tell you, I will. I'm going to get control of this thing if it kills me. So let me go backwards. Okay. All right. So first we're going to do some analysis. I'm going to talk to you about a packet. All right. And so we're going to take a look at a DNS packet. So how does DNS work? You have a request, and then you have what? A reply, right? Now, I want you guys to tell me where this DNS request came from. Stare at this a little bit. Stare at this, and you'll be able to tell me exactly who created this request. Who was it? It was Facebook, right? It was Facebook, and one of the things that we see in here is this address, 2620 Charlie 00, what? FACE B00 Charlie, ::::2. What do you bet they got a :0:3, right? And a :0:1, right? And so if I'm a hacker and I want to start getting into Facebook systems, what am I going to do? What am I going to do? So this is really, really interesting, isn't it? Is that when people start giving addresses, you have to be very careful with your numbering scheme. Because what happens with IPv6 is that people think that, it's very confusing, and so I'm going to give you an addressing structure that sort of makes sense. But when you do an addressing structure that makes sense and publish it all over the world, well, you get something like this. And so that's interesting. What else do we see in here? This is an interesting packet here. It's a quad A. It's a quad A DNS query, and it resolves to that address. Let's just double check here our analysis of this packet and see what we have. Okay. And the other thing that you want to look, of course, in your DNS is you want to start looking at the response times for your DNS requests and responses. Because the other thing I'll show you is traces of what we did on World IPv6 Day. What we found is that a lot of resources did v4 and v6 queries. Some of them resolved, some of them didn't resolve. The other thing I'll show you is you'll start seeing multicast DNS, v4 and v6. All that kind of stuff you want to see. You want to start looking in your lab, see how you're configured, and then you can see. So now, let me show you, we'll go through a case. I'm going to show you a typical problem. Again, I deal with enterprises a lot, and this is a problem I was involved with last week. Very typical problem. There's a business partner, and they're having problems with an application. We had the application developer on the line and the network technician, and the application developer said, we tested, we put a higher speed link on that, and everything ran a lot faster. This is not our problem. It's obviously your problem. It's a network problem. Of course, what does the network technician say? Network technician says that the window size is set very low, so your configuration is wrong. It's set to less than 4,000, but even that doesn't even matter because the bytes in flight are only 1,000. Yeah, I'm going to talk about what bytes in flight are in a second. So obviously, it's your problem. Very typical. I run into this all the time. I bet you guys do too. This is a very typical kind of thing. It's not my problem, it's your problem. So one of the real ways that you start trying to figure all this out is how? It's through tracing, through packet. Look at the packets. What did I say? Packets don't lie. So what you got to do is figure out a couple of things. First is bytes in flight. Your congestion window is like the speedometer. That's how much you could send. But how much are you really sending? And that's bytes in flight. So congestion window is set real low. That's set to just 4K, but you're not even getting anywhere near there. You're only sending 1,000K. Something's really wrong, you know. You have set something really bad. You know, you're doing something in your application that's poor design. That's what the network technician says. So, but what I'm describing to you, you guys say, this is an IPv4 problem. This is an IPv6 forensics thing. Why are we talking about IPv4? Well, isn't it the same? Isn't it the same in v6? I mean, don't we have applications in v6? So aren't you going to start getting into the same kinds of issues? Has that changed? Of course not. What I'm trying to say is that forensics at a lot of levels is really the same. You still have to use the same kind of methodology. Congestion window, bytes in flight, throughput, all that kind of stuff you have to remember. Because just because you made the address bigger doesn't mean you change the entire way of doing forensics. But that's not exactly true, because at the packet level, a lot of stuff has really changed. When you get into breaking out that packet and looking at everything, there's a lot of things that are different, because the packet's going to have extension headers, like the other young lady said, tunneled packets. Addresses are going to look different. You got DNS v6, all this kind of stuff. So we'll take a look at some of that. So having said that, the big structure and the methodology is the same, but when you get to the details, there's some differences that you got to look at. So in this kind of case, and in very typical kinds of cases, forensics is important. Things like, as I say, congestion window, bytes in flight, how many bytes per second are you transmitting, you know, all that kind of stuff, packets per second. The other thing that people come into is like, I made a topology change. What was it like before and after? Again, the very same things need to be calculated for this. Now, if you're the application, then you have to say, is there a delay in responding? Again, you can look at the packets and find out if there was a delay in responding. So I'm just going to show you a couple of things where we go ahead and calculate the throughput. And you can see, so you've got your connection time, how much it took for the connection to go. For example, this one, let's just take this one. We took, and we have 85 seconds for our connection time. From this address to this address. This happens to be a V4, here's a V6. We had a couple of different, we had a mixed set of connections. See what I said? Is like, this is when you start having fun, is you've got mixed connections on this link. What's the difference in throughput? Start looking at that. Because what do people ask? Is I've just changed over to V6. What's my response time? Has my throughput gone down? That's the first kind of questions people are going to start asking you. So this is, as I say, what you want to calculate is things like this. The throughput in packets per second and so on. I tell you, we use this kind of stuff all the time because the questions we get are like, okay, we had problems, we made changes, what happened? Did it work? Did it not work? Let's take a look at throughput a little bit, because throughput is very important. Throughput you have to calculate both ways. Why do I say that? Because TCP is full duplex. You have traffic going one way, you have traffic going the other way at the same time. And the throughput can be different for both connections. And so you have to calculate throughput and bytes in flight for both sides. And here I'm going to take an IPv6 connection. First, I calculate the bytes per second, minimum bytes in flight, average bytes in flight, and maximum bytes in flight. This actually looks really, really terrible because I have very few bytes in flight. Of course, I have very few packets on this. This is a test connection. Otherwise, I'm looking at like 123 bytes. I mean, this is just terrible, just terrible. But of course, it's probably just my SYN sequence. I mean, just very few bytes. But as I said, this is the methodology. Go ahead and do it this way, and then let's go the other way. And again, I'm going to eyeball right down, say, what's the maximum throughput? What's the maximum I'm sending across this connection? It's very, very low. And so, as I say, this is the kind of thing that you want to do when you're looking at throughput. Now we start getting even deeper. If we really want to start understanding, I'm going to show you a quick tunneled packet, and then we'll talk about DNS. We'll pull back up and look at DNS. So tunneled packets can be very hard to look at because they've got 4 or 5 different layers. This first layer is the IPv4 layer. I'm going to show you, this happens to be a tunneled packet using the tunnel broker, the gogo6 tunnel broker. We traced that. So here's V4, and then you've got your UDP header in there. We're going to start looking at UDP. So here we're using source port 1435, dest port 3653, and we see in here tunnel broker protocol. We've broken out this packet to see that it's tunnel broker, and there comes our IP6 header. Because what's tunnel broker going to do? He's going to tunnel IPv6 inside a UDP packet. So that's interesting here. Here comes our V6 header, broken all out, and then our extension header that we've sort of talked about in some instances. This one happens to be an ICMP-v6 header, so we're down another layer. Here's our, here in the V6 header now, here's the real source and destination addresses. To pull back up, if you're going to start doing capacity and all that kind of stuff, bytes in flight, you've got to do it for this V6 connection. Does UDP have congestion window, bytes in flight, and so on? No, it does not. However, if you've got TCP tunneled inside of it, does that have congestion window? You bet. You bet. So it's a very interesting, you've got to go one more layer to start calculating. So that's an interesting, it makes it much harder, of course. This one happens to be ICMP-v6, which is not going to have anything like bytes in flight and so on. But of course, you want to know what it is. So there's a couple of different things. One, be sure that whatever you've got, whatever tools you're using, are breaking everything out, tunneled, not tunneled. 2, make sure you understand what just happened. Other thing that we try to do is we take a look at, you want to analyze your neighbor discovery protocols. As I say, one of the things we started doing is, I tell you, when we're doing so many of these things, I'm like, you know what, let's just build something so that we can see everything coming through. So I can just read it like I would a book. And we just turn it into something that I can read. So then I'm just looking at what's sent. Neighbor advertisements, neighbor discovery. Is it a duplicate address detection, or is it one of the runs that flows regularly? And then, what's the rate? What's the rate at which I'm getting neighbor discovery? Why do you need that? Back into your configuration, whether it's your router configuration, whatever, you can have the ICMP rate limit. If you don't know the rate at which this stuff is coming out, how are you going to set that rate limit? So let's talk about DNS. DNS is very, very interesting in V6. It's one of the things, as I say, first thing you go out in your lab, first kind of problems you get are going to be DNS. That's what the people that I'm working with right now, they're putting stuff up, and they go, oh my God, first thing that happened is did I configure my DNS right? So I'll show you some. And some of the stuff, as I say, are from traces that we got on World IPv6 Day. First thing we did is we went through and tried to figure out what the performance was. You know, how many bytes, how many, you know, how much data it was, and then the response time. Because DNS is a request response kind of a protocol. So you want to know what's the response time. And you're seeing here, you're seeing the max response time at being over 1 second for some of this stuff. And so immediately you're thinking, ooh-wee, if I've got more than 1 second, something's going on here. Now, what is this for? Is this associated with an error request, or is it a normal request? Is it for V6? Is it for V4? What just happened here? As I say, the first thing you want to know is, what am I doing here? Because as I say, it's something you want to figure out. Other thing we figured out when we started doing traces is, look at all this stuff. We started seeing tons and tons of stuff going over port 5353. What is port 5353? You guys? Multicast DNS. Woo-wee, multicast DNS. And what is this? 224.0.0? What is that? IPv4 Class D address, right? It's a multicast to IPv4, and we're seeing all kinds of stuff going out to resolve that. What is FF02::FB? That's the multicast DNS address for all multicast DNS servers in IPv6. So this was very, very interesting to us, that we see a ton of this kind of stuff going out on, you know, from all these DNS servers, both to resolve V4 and V6 addresses over V4 and V6. So this is what I say, is you want to look and see, what the heck have you configured on your DNS? Are you doing this stuff? If you're doing it intentionally, well, wonderful. If you're doing it not so intentionally, well, you want to take a look at that and see what it is that you have actually configured. Here's this. The other thing we see is we see all kinds of queries. We see both A queries and quad A queries going out. A lot of times when we see on World IPv6 Day, every time a request, every time it's something, we did something, we saw both an IPv4 DNS query and a V6 DNS query going out, even if one of them was already resolved. And that's a huge waste of time, waste of resources, and higher response time for the customer. So that was really interesting for us to see. And then, of course, we want to analyze all that and see exactly you know, what was going on, if there was errors, and exactly how much time it took. As I say, you know, one of the packets don't lie. Packets don't lie. You want to go through and you know, figure out exactly what you've been doing, and so it, you know, it keeps everybody honest on this thing. As I said, I just picked a couple of little things. I picked tunneled packets. I picked DNS, and that's just two little things. You know how much more there is in this whole area. It's a really good learning exercise too. You know, once you look at the packets, you do the tracing, you know, you break it out, you feel like, you know what, I really kind of got a handle on this. You know, I really understand, you know, what's going on, and I feel like I have a pretty good control of my network, and then I can move on to do new things. So, as I say, get ready before everything starts. So, okay.